Um, so the first part here, just finding the arc measure and stating what kind it is. When do you have to use, and on your worksheet, it may not have said measure there. It really should say the measure of the arc. I was copying and pasting from somewhere and they didn't quite have the notation right, but it should say measure. When do you use 3 letters? When do you have to use 3 letters? Let me say it that way. Why?
Semicircle.
To do what?
If it's a major arc or semicircle.
Yes, if it's a major arc. How do you know if it's a major arc, Julia?
If it's bigger than the semicircle, so bigger than 180 degrees.
Right. So if we say, for example, GHI, okay, what I meant to say, yeah, GHI is from G through H through I. You don't have to use 3 letters for that angle measure, okay, because it's not a semicircle. But if you wanted me to go from G to I the longer way, you would need to say GJI, which is this one. It's not wrong to use 3 letters. Like I said, that one over there is 119. It's not wrong to use 3 letters there, but you have to use 3 letters if it's a major arc. So just for kind of efficiency, we typically only use 2 letters for the minor arcs. Semicircles technically should also have 3 letters because even though the measure is the same, you should know whether you're talking about that arc versus this arc. So we'll usually use 3 letters for semicircles as well. Okay, with all of the stuff that we'll do with circles, instead of using 3.14 for pi, we're typically going to either leave your answer with a pi in it. You know how I say exact and simplified with radicals? It'll be the same idea with pi. In terms of pi means leave a pi in your answer. If I have you use the calculator for anything, it will be, you'll be using the pi button. So you'll do, if I say like approximate that, there's actually a pi button on your calculator, which, let's see, on a graphing one, it's second function, then the little caret above the division, multiplication, subtraction, addition. On a scientific calculator, there's probably just a button that says pi. So if I was doing 32 pi, I would have you do 32 second function caret. Okay, and that's a better approximation than using 3.14. Pi is irrational, which means it goes on forever and it doesn't repeat. So when you use 3.14, you're leaving out tons and tons and tons and tons of digits. Sometimes that matters more than other times. Okay, but see on this one, 100.5309, et cetera, et cetera. That 32 pi expression would go on forever because you're multiplying 32 by an irrational number. It's just that your calculator can't show you a number that goes on forever. So it has to cut it off at however many digits you tell it to cut it off. So if, for example, I went in and made this, I just want to see, oh, this looks different than how yours looks. You'll have, if you're looking at a graphing calculator, it'll say like, how many decimal places do you want it to go to? Oh, I guess that's here. Okay, so if I made it go to like 3 decimal places, then and I do 32 pi, it's going to cut it off even more. Okay, float means kind of do the best you can. Give me the like least approximating number as possible. But obviously it has to cut it off somewhere. So float is what you set it on when you're trying to get like as many digits as the calculator can display for you. All right, but just know that unless the problem says use 3.14 as approximation, which hardly is ever going to happen, you should be using the pi button. All right, so for the arc length, so for like this one, for example, remember that the length of the arc, so if you have a circle, it said that the central angle measure was 45 degrees. And remember, this is the same idea as when we talked about central angle with the regular polygons. The central angle is formed with center point, and then 2 radii, making your central angle. So the diameter of the circle is 3 feet. That means the distance across here would be all the way across be 3 feet. And on this one, I wrote it as pi d instead of 2 pi r. So we can just plug in the 3 there. If you write the formula with 2 pi r in it, you'll be doing 3 divided by 2 and then multiplying by 2 again. Okay. So for this arc length, we're saying it's a fraction of the circumference. Okay, the circumference, if the diameter is 3, the circumference is 3 pi. So we're just doing a fraction of the circumference. That represents 3/15, 3/60ths of the circle's circumference. So the whole circle, the whole entire way around would be 3 pi. We don't have the whole way around. We only have a fraction of it, which is 3/15, 3/60ths. Okay, and then on that one, I asked it around to the nearest tenth. But again, I would do 28 pi button divided by 8. Okay, questions on the ones in the middle there? When we're talking about a tire revolution is referring to circumference, if that's not obvious. Oops. Questions on the middle 4 on that page? Okay, here's the ones at the bottom. Sorry, I'm trying to put a right angle there. It's not correct. Okay, and again, arc length is not a degree answer. It's how far you would have to walk from one like endpoint of the arc to the other one along the circle. So this one is a minor arc, so that's less than 180. Okay, 60, 3/60ths is 1/6. I do this a lot, but you honestly don't have to simplify those. You're going to type in the calculator anyway. So if you wanted to just do 60 3/60ths times 30 and get 5, that'd be fine. Usually these numbers are rigged up to where those fractions are decent numbers. But if it doesn't come out to be a whole number like that or an easily recognizable number, then you would want to go back and kind of work with the fractions. So for the last one, you can do 270 3/60ths and say that that's 3/4 of the circle. Or if you want to just do 1/4 of the circle and then add it, well, there's 2 ways you can do that. You can do a quarter of the circle and add it on to a semicircle, or you could do 1/4 of a circle and subtract it from the full circumference. This is what I think is easiest. Okay, just think you have 270 3/60ths of the full circumference, but there are other ways of doing that. So kind of whatever your preference is. Questions on those 3? Okay. And then here's a few more that are dealing with arc measure. Okay, arc measure, we're talking about 360 degrees. Arc length, we're talking about the circumference of the circle. Now, it's perfectly fine for you to, like on the third one, if you prefer to just add those up to 270, that's fine. Like basically subtract the 90 from the 360, and this arc measure is 270. So if you wanted to just make your equation, those add up to 270, that'd be fine. Kind of whatever makes best sense to you. Questions on those 3? Okay. ones at the bottom here. Let's just look at a couple of them at a time. So for the first one, that's just two trapezoids and they're congruent to each other. Okay, so you find the area of one trapezoid and then you can just double it because the base lengths are the same. The heights will be the same. Okay, for this one, if you did not realize that you're subtracting areas there, when you cut off, like when you kind of complete the square there, what you're doing to find the area is you're doing the square's area minus the half of the circle's area. And then you're subtracting them. If you want to do the area of the semicircle by just doing pi r squared is 16 pi, and then cut that in half to get 8 pi. I kind of wrote more than you really need to, maybe. All right, and then for the two at the bottom here, so on these you're adding areas. So for the first one, you have a trapezoid and a semicircle. Okay, be careful that you pay attention to the fact that to do the area of the semicircle, you're doing 4.5 squared. The diameter is 9, so the radius is 4.5. My preference is typically to leave it as a kind of like the fraction form, but it's not wrong to put it as a decimal because 81/8 is exactly the same thing as 10.125. Just like you could put a radical with a decimal in front of it, you can put a decimal with pi, but you shouldn't do that unless it's exactly the same as the fraction form. Do not round. Okay. On the last one, you have a little square, and I know that's a square because it's 13 by 13. Okay, and it said you can assume like it kind of looks like what it says it like what you think it is what it should be. So it really is a square there, not just a rhombus. And then that's a trapezoid, and then this is a semicircle. So you do all the separate areas and you add them together. And again, you can put that into decimal form, or you can leave it as a fraction because 225/2 is exactly 112.5. Okay, what questions do you have on the bottom of that page? Nothing? Okay, so this chapter is called Areas of Polygons, but we're going to do a bunch of stuff with circles. I don't know why they didn't just call it like areas or something, because we're doing areas of polygons at the beginning of the chapter, and then we get into the second part of the chapter, and it's a bunch of stuff about circles, which obviously are not polygons, so I don't know. But I'm not going to do anything new with you today. What I want you to do is go to Schoology and import tonight's homework. What you're trying to find is the shaded area. So for example, for the first one, how would you find the area of the shaded part? So kind of strategy. I'm not going to work through all the details because this is your homework. I just want to kind of talk through the idea of what you're going to do. How would you find the shaded area on the first one?
First you'd find the area of the, or I guess you could do it in either order. Once you have the area of the circle, you could get the area of the square or rectangle, and then you subtract the area of the circle from the area of the rectangle.
Okay, so because again on this one I said that you can assume that all polygons are regular, that is actually a square. Okay, when you're doing these areas, I would really like you to kind of specify what you're doing when you're doing it. Area of a square equals area of a circle equals, or what I just did is even this. When you refer to a circle, you draw a little circle, you put a dot in the middle, like that's circle C or whatever. You name that. I don't know if I said that in this video. I don't think so. We're going to be doing more with circles as we go through this chapter. So when you name a circle, so like if the center point was C, you call it circle C. That's how you know that it's a circle and not an O. Okay, so that's why I put that little dot there. Doing that, it's a little unclear what that is. All right, so what do you have to know in order to do the area of the circle? Well, you have to know the radius. We do know the radius of the circle, right? What are the dimensions of the square? I want someone to talk who's not Paul. Not Paul and not Julia.
12 by 12,
How do you know?
because the diameter of the circle is 12.
Okay, so when you're looking at the pictures, sometimes the way that they'll draw the radius or the diameter is not necessarily very helpful in terms of where it's drawn. You want to realize since the radius is 6, that means this would be 6 and this would be 6. So the whole side there would be 12. And you can do the same thing horizontally. So this square is a 12 by 12. Okay. So for this one, again, you're going to be doing the area of the circle minus the area of the triangle. Now, in order to do the area of the circle, we need the radius or the diameter. So we have to draw something on here. Now, remember, I told you that the polygons are regular. So you need to pull back into your brain things you know about this regular triangle. So do we know how to find the area of the triangle from what we were given so far?
Yes.
Okay. Ainsley, how would you find the area of the triangle?
You would do like the side squared formula. So you do 6 squared times the square root of 3 over 4.
Okay, so that's a regular triangle. You know the side length, that's exactly what I would do. I would do the s squared root of 3 over 4. When you go to do the area of the circle, do we know the radius of the circle? Carson, do we know the radius of the circle? Like from what we're looking at right now?
No.
No. So this is not a diameter, right? That means we don't know a radius. All right, do we have any ideas about what to do to find the radius? Anybody who has not answered?
Find the apothem.
Paul? Nope. Anyone who has not answered a question, can you tell me how to find the radius?
You could find the area of all 3 semicircles because you know the diameter, and then add them up.
Okay, you're saying semicircles. You don't really mean semicircles, right? You mean the third of the circles? You're saying this, yes?
Yeah.
This. Okay, those are actually called sectors. You don't know that yet because we haven't talked about that yet. But it would be true that the area of the circle is this multiplied by 3, but you would still need to know the radius, right? In order to do the area of that fraction of the circle. So it helps for me to draw in a radius like that. What do you do to find, so this is what we're looking for. This is what we're looking for. That length right there is the radius. Or if it's helpful to draw it in a different, you can do it like.
Couldn't you just take the side length of the triangle and then like do 2/3 of that? So it'd be 4.
The 2/3 is, I like what you're thinking, Joey, but the 2/3 is if you had the altitude, that segment, that radius is 2/3 of the altitude's length. You can use the altitude, but it's not 6. So both of those things could be helpful, but just be careful that because the altitude length is not 6. Guys, what do we know about regular triangles? I need some angle measures. What do you do? Paul said find the apothem. I mean, you can find the apothem, you eventually have to find the radius. What do you do to find the radius? I've got a little triangle right here. A little triangle right here. Do we know any of the dimensions of that triangle?
Oh, that's a 30, 60, 90 right triangle.
Yeah. So this will be a 30, 60, 90. Do you know any side lengths of the 30, 60, 90 triangle?
The one across from the 60-degree angle is 3.
So since the whole side of the triangle is 6, that means that's 3. Jake, tell me how to find the radius and the apothem. We're trying to find the radius, but probably got to find that first.
The radius would be 3, or it would be 6.
Do we have the long leg or the short leg?
Oh, we have long legs, so it'd be 3 root 3.
Okay, it'd be 3 divided by root 3, and that's simplified.
Oh, 3 divided by root 3.
But the idea is, and again, you guys are going to work out the details here, but the idea is you've got to be relating the regular triangles to the circles, the regular polygons to the circles. Okay, so sometimes they'll give you what you need for the area of the circle. Sometimes they'll give you what you need for the area of the polygon. Sometimes you'll have to kind of use whatever's given to figure out the rest of it. Okay, but same idea here. Usually it's helpful to either draw in a diameter or to draw in some kind of central angle, depending on what you're given. So like, you know, you can do that. You could do divide it into 2 pieces like that. But you have to be careful that, like, again, this length right here is not a radius or a diameter. That's called a chord. And again, we haven't talked about that yet because that's something that we'll do after 10-7. We jump into more stuff about circles. With a chord, you're just picking any 2 points on the circle and joining them together. Okay, that's called a chord. So just be careful you're not oversimplifying it and thinking that those are radii or diameters. Okay, for this one, it's probably helpful to go ahead and extend that out and make that a right angle there. Kind of see what you can come up with from that. You can always draw, again, this is not a diameter or a radius of the circle because this is an inscribed circle this time. Okay, but you want to kind of focus on the triangle to figure out the area of the triangle and to figure out how to get the radius. For the area of the circle, you always need a radius or a diameter. Okay, so I told you A is 10 for number 5. You know, like I was just trying to make it easier for you to have an actual number there instead of asking for like a formula or something. Okay, and again, this is a regular triangle. So I'm not going to give you any kind of hints on this one. I want to see kind of what you can figure out from there. And then for this one, it's helpful to cut it into parts. Figure out how to cut the square into parts. And then add, subtract, whatever to find the area that's shaded. Okay. All right. This is your homework for when I see you on Wednesday. And again, I'm not doing anything new with you. We're going to let the arc length and arc measure marinate for a little bit. And then when I see you on Wednesday, we'll be doing the next lesson, which will be areas of sectors. So I think I mentioned that a minute ago. That was if you have a circle and you want to find the area of what's called a central angle here. If you want to find an area of that sector, how you find the area of a sector like that. And then we'll also talk about how you find the area. This is called a segment. When you draw a chord and cut off a piece of the circle, that's called a segment of the circle. So on Wednesday, we'll be doing more area stuff. But so instead of arc length and circumference and arc measure, we're going to be talking about areas of sectors and areas of segments.